recorded live.
Hello and welcome to the Virtualization Security Roundtable podcast episode number 100. Hopefully we'll be having a bunch of guests stop by throughout the show. If not, it will be myself, Edward Hletke, aka TechSciWill in the VMware Communities Forum, and author of VMware vSphere Virtual Infrastructure Security. And also joining me is Michael Berman, who is now a member of the technical staff at a stealth company. Is that the right way of saying it, Michael?
That's fine. And the company is named TitleScale, for those of you interested.
And just go ahead and look it up on the web, titlescale.com, I'm imagining.
Yep.
And hopefully joining us later will be Eben Rodriguez, who is an IT industry veteran, now serving as a cloud solutions architect for CA Technologies. And some of our original members will hopefully be popping on periodically. So, Michael, there was actually some interesting news this week, and there's actually a lot of interesting news as we gear up for RSA conference. I'm starting to get my mailbox flooded with all the new security things that are happening. And one of the ones that came up that was rather intriguing was VMware's investment in Puppet Labs.
Yep. Did you happen to notice how much of an investment they made?
$30 million. It was to me that's significant.
Yeah. What was the valuation? Is it a significant? I mean, I suppose that's a significant percentage.
I don't know. From what I've read, I don't know what the valuation is. I'm not a financial person, you know that. From what I read, it was so that they can get Puppet in it tightly integrated with their VK API, which is their cloud APIs, as well as with Orchestrator and a few other things that they're working on, some of which are public information, some are not. But it's interesting. This is not the first time they've done it, though. They've invested in Puppet before.
Right, which maybe also implies that Puppet is going through a broader fundraising round, and VMware was making sure that they don't get diluted by this forthcoming round. I also find it interesting because, to me, this indicates VMware's continued intent on, at the management layer and the orchestration layer to be broader than VMware itself. Puppet is certainly a well-regarded cross-platform heterogeneous management solution. And so this, to me, indicates a continued dedication on VMware's part to provide a bigger solution at the management layer than just for VMware itself.
Absolutely, but also Puppet has been used extensively by security professionals as well. I mean, people
it's got
automated access to firewalls in the past and all sorts of security devices, effectively anything with an API.
Correct, and Puppet provides capabilities for you to wrap your access in secure authentication and secure transport mechanisms. So it's definitely a well-regarded tool, and I'm a fan of it myself.
Oh, I am too, and you tie that with some of the other tools that are out there, you can actually do a lot of interesting security work. Matter of fact, I wrote about this morning, and that is that I think you could use some of these tools like Puppet, like Chef, to provide a feedback loop that could be beneficial for security. In other words, attack detection. I mean, this has always been the problem. You detect an attack, but how? Most attacks are detected, I think, almost by happenstance, right? You just happen to be looking at the log at the right time.
Well, people tend to say that. I have a different take on that.
Oh, please, share.
Right. Well, an attack is detectable because you have the tools in place that make detection a realistically, a likely event, a more or less likely event. And, we're well beyond, there was a famous book written, I'm shy to say how many years ago, I believe it was called The Cuckoo's Egg, and it was about the attack on the Lawrence Berkeley labs. And,
yeah, it's a well-read book, and it should be read by everybody in the security field.
Right, and a physics researcher, and I would what you said sort of well characterizes that. I mean, a researcher just happened to be looking at a bill, noticed a slight discrepancy in the charges, and in tracking that down.
What was it? Something like 13 cents.
It was ridiculous. Only as someone with a mathematical background would have cared, right?
Yeah.
And you could say that was complete luck, and certainly in that case, I think there's a strong argument for complete luck. But one must also recognize that the right person was doing the right thing, right? The person responsible for costs, who understood the costs and what they ought to be, was looking at the charges. And I think that is as true today as it was then. You could argue luck is always a factor, but I think having the right tools in place, having the right logs, having the right log analysis, no matter how good your log analysis is today, probably in the production data center, you don't necessarily, and this could be a failure, don't get me wrong, you don't necessarily respond to an attack until a human being looks at the log. So, of course, the story is always going to be, I was looking at the log, right? But the deeper question is, why did you have that log at all? Why were you looking at the log? Hopefully you had that log because you knew you should, and you had a standard practice of looking at it.
Well, I think that's actually you're looking at a subset of the log. No one's going to be looking at the full log. And the reason being is, like, even in my small little data center, I gather every day gigabytes of log files. Gigabytes. I need something that reduces that to something that means that I can look at. So, we have all these GRC tools and SIM products to do all that massive amount of looking at to reduce it to something a human can understand. What I'm saying is it needs to actually go further than that. I think that the next-gen security, the software-defined data center security, actually has to be software-defined detection in an immediate feedback to say, hey, we detected this problem, we know it's an attack, feedback to the security subsystem, say, now look for that. But that's always been a tough thing to do. I agree
completely. These things must be more automated. And, in my former position at Catbird, one of the things we did there was we worked on what we call workflows, right? That the security tools support a workflow, and that workflow can be human in the loop or, machine-driven, where machine-driven, the action, the response, the feedback is done without human intervention.
Exactly, but the problem with that is that you could do an action. I mean, for example, one of the customers I deal with on a daily basis is, and I look at their reduced log file set, they capture all sorts of interesting attacks against their website. We have to make a decision on how to implement those. The problem they have is that one machine behind a natted firewall represents that attack, where there's 50 other machines that don't. So even for that single IP, if I just block that IP, I could get 50 machines worth of data, good data and useful data and stuff that moves the business along, and there's one in there that is not, and you penalize that one. IP isn't good enough for this particular case, because it actually, if you start blocking by IP, even over time limits, you start impacting the bottom line.
Right, but I wasn't proposing one particular method of detecting and resolving an attack. I was merely saying that we must move to a much more automated regime where some attack mitigation, if not all, may become machine-driven.
Can we get there
without immediate, human oversight?
Can we get there, though, given that what may appear to be normal may actually be an attack, at least by the log files? I think it's because we just don't have the instrumentation to do it today.
I would, in general, disagree with that. I think in the specifics, you are right. There are kinds of attacks.
Still there, Michael?
I'm there, sorry. I was sticking to mute, as we all tend to do. What I was saying is I would disagree with that in the specifics, but not in the general case. I would actually argue you could make a general argument that with the proper sensors in place, you can know enough to properly characterize some kinds of attacks sufficiently to know that your automated response is the correct response. There of course, are going to be attacks that are not as clear, or there may be attacks you don't have sensors or insufficient sensor coverage for. But I wouldn't make the universal statement that, all attacks are sufficiently vague that, automation can't handle them. I don't believe that's the case.
Well, what about this concept? I mean, there's the concept of surrounding the attack, sort of the Bromium and semantic CSP approaches, or the SC Linux approach, where they whitelist everything that is allowed and disallows everything else. It's kind of putting a moat or surrounding the attack. So an attack comes in, yeah, it's there, it's successful inside of that chunk of code, but it can't spread any further.
Well, that's an attack mitigation strategy, right? And sandboxing
kind of
or jailing an attack is certainly a good strategy. That may in fact be a response, right? You could automate a response where you take a VM that you believe has been compromised and sandbox it and spin up a production replacement from known good source, right? And then allow that known good VM to continue to operate while the infected VM is jailed and awaiting human inspection. But I was also saying that your earlier scenario where we talked about IP addresses and you can't just block an IP address. Others would argue, certainly people in the context-aware space, that you can perhaps understand the attributes of an attack, not block IP addresses at all, but but respond in a way that this pattern of network activity is being blocked, irrespective of IP address. And what you've done is whitelist the appropriate, right, the proper network activity, and you then effectively blacklist not an IP address, but an activity that is malicious.
So basically, you're saying with a known good that, and this actually has to be incredibly intelligent, because say my application allows me to have these 20 or 30 different variables passed in as part of its RESTful API or whatever I'm using for that transfer, let's say HTTP. I need to make sure that if I'm making changes, I got to reallow even more variables to go through. Then you need to worry about, there's a lot here that needs to be taken advantage of, I think, further down, long before it hits the infrastructure. Let's just say that.
Or it could be transparently handled by the infrastructure, right? If you have, authenticated network access, right, where regardless of what's inside the datagram, so to speak, you have the proper, signatures and seals around that datagram, you've narrowed your threat to, situations where someone has, subverted your signature authority. But, a wide range of attacks you can now, simply discard, because they either won't be authenticated at all, or they'll be improperly authenticated. Just the way we might, check signatures in PGP protected email and determine that it's a bad signature and not even open that email.
So how would this work for general applications that are open to the public? Everybody has to use HTTPS? The problem is that if I start saying that I have to have authenticated traffic, that alleviates all web servers from ever having that. Because SSL has so many weaknesses that the attackers use it.
Well, SSL has weaknesses under which specific circumstances. I'm not saying SSL is the panacea. I'm just saying, one can construct a network such that, your known good traffic is readily identified, right?
I think internal to your data center, I would agree with you. I think as part of your DMZ or the web-facing, customer-facing systems, you probably cannot do that easily?
Well, I think if you understand your public-facing web application sufficiently, you can. And I'm not saying anybody does this, and I'm not even going to argue it's feasible in all cases, but in a narrow enough case. So let's say, my bank is ING. And for those of you interested in attacking me, it's not. I'm just making that up. Let's say my bank is ING and I do web-based banking with these guys. They could sufficiently characterize their own application such that they know proper, query or post and other syntax, how their application is used.
So you're actually answering my own question for me. And my own comment, that is that I still think that this needs to be pushed further into development because those are the ones that are going to have to code up the parser that says this is acceptable, this is not.
Right.
I don't think you can put that outside the app.
Exactly. For web applications in the DMZ, I think that's a fair recommendation to make. And in fact, it should be part of their coding methodology. It should be part of their unit testing, right? That as they're developing web code, be it in PHP or Java or Python or however they're doing it, they should be developing, input-output testing modules as part of unit testing, where it's going to validate that only correct input is being provided. And anybody
you and I
who is
both know that they don't do it.
Well, they certainly don't do that enough, and many people don't do it at all.
Exactly.
Yeah.
It's almost like you need to have security tools that tie into the development process. So the ones I keep on coming up with are the Fortifys and Core Impacts of the world.
Right, and other people who claim, if you code in their environment, they prevent you from, implementing something that's vulnerable to cross-site scripting, for instance. I was just looking at that the other day.
Exactly.
Yeah. It's basically you make this part of your integrated development environment.
And if you can't, then you need to containerize it, which means that you may end up having to put a proxy in front of everything.
Well, that's what a WAF is about, right?
Mm-hmm. But the WAF is not trained necessarily on what's known good.
Right, but I think most WAFs can be trained. Right? Certainly the enterprise-grade ones can be.
Absolutely, and if you can train them, if you're thinking about scale, the first place you should do it, if you know something's going to scale out to 1,000 virtual machines or tens of thousands of nodes, I think the first place you need to do it is at development.
Yep.
But if it's way too late to do that because the coding team is just not trained enough or no one's actually gone through the effort, then you need to seriously consider, and this is actually what I think you should be considering as a second line of defense anyways, is a web application firewall that you can train for the known inputs.
Right, because even an untrained WAF has the basic SQL injection and other, kind of really obvious attack applications in place. Yeah.
Like trying to get your password file and things like that. It knows to say, sorry, go away.
Exactly.
But I've had this debate with a lot of security vendors recently about sandboxing and whitelisting and application protection. Is that the application itself? If I go in through a known good path, but suddenly I'm down another path in the application that I never expected it to go down. Maybe everything was accepted on input. I get down and the input was interpreted differently, or whatever.
Right.
These types of attacks happen as well.
Oh, sure. People play games with character set, Unicode variations.
Exactly.
To fool the parsers. Absolutely.
And they'll get in, and then once they're in, they're able to do some sort of damage or get some data or something that they don't expect to be able to do, and finally that becomes an attack. There's a lot of research going on in that today. But when you start talking about scale, though, how do you prevent things like that?
Well, the question would be is, can you establish, a secure, multiple security domains, and therefore, put, your front end piece of the web application in one domain, and other pieces, other data, other customers' data in different domains, so that if a particular thread is compromised. So again, let's go back to ING, and my account is compromised. That's tragic for me, but it shouldn't be tragic for anyone else. But again, we both know that sometimes that isn't how it works. But if the web application is constructed properly and we have these different security domains, it certainly could be that way, so that the damage is contained to my account only. It doesn't cause other customers problems.
And this actually ties to the software-defined data center in that, we're talking about multi-tenancy here. I think that secure multi-tenancy has to be the bedrock of any software-defined data center today. And I'm not sure. Right, and we would then argue that it needs to be MAC, not DAC. Mandatory access control, not discretionary. So again, no, I would agree with you. I would prefer MAC.
Yeah.
But I think that the bedrock is the part of SDDC that has to be, before anybody says they have a software-defined data center, I would like to know that they have true secure multi-tenancy.
Right, which brings us back to something you said earlier, and something that I used to speak about at length, which is you need to have to secure these things at scale, you have to have a software-defined security model, because you have to be able to grow and shrink and deploy security on demand. It has to, flexibly create these security domains as needed by, not just tenant to tenant, but even within a tenant for compartments for each tenant.
And you need to have any type of break in that security or fault needs to be detected immediately, needs to feed back so that it can go forward.
Right, and what's nice about that, so, the term of art I use is zones of trust or trust zones. If you have these security domains, these security zones, and you have characterized your application when it's behaving properly, which zones are crossed, which zones communicate with each other, right? You know when that boundary is crossed, by what application that boundary is crossed, ports, protocols, you can very, very specifically define the proper attributes and control for that. And then when you see something that doesn't match that known good set of attributes, you have something very suspicious going on. At best, a misbehaving application. And even under a misbehaving application situation, you might be better off automatically blocking it, right?
Right.
Maybe not necessarily spinning that VM down, maybe not jailing it, but certainly having those capabilities at your fingertips should that be what you want to do.
Well, I would agree with you there. But when you look at, we look at security today. I'm always looking at new security products, and I'm thinking that for small environments or even medium-sized environments, I think they all work. But when you start talking about environments where there are 40 to 100,000 different virtual and physical nodes, and probably 40 to 100,000 or more end-using computing devices such as iPhones and Androids, I'm not sure much scales anymore. What do you think?
Well, that kind of scale is hard, and, we're actually faced with much, I'll argue even, another order of magnitude beyond that we have to be able to manage.
I agree with you.
And I'll come back to what you said earlier. Tools like, Puppet, are, I think, able to operate at that scale. Products like my former company's product at Catbird and others need to operate at that scale if they don't already. We have to have those capabilities, or people aren't
won't be able to deploy them, right? But, I think, a lot of these tools can be caused to scale with some complexity, right? You either have to have manager federation, you have to have some kind of manager's hierarchy to a certain depth, and then you can get these tools to scale. And we've seen that even, going back again with VMware or other tools, vCenter only scaled so far at first, and now vCenter scales further. But if you want to scale beyond that, you've got to go to like a vCloud Director or orchestrator kind of solution. You have to build that scalability on top of what the native tools can do, because you may have to deploy many manager instances because individual managers can only scale so far.
True, and it's not only that. I mean, for example, yesterday the VMware Communities podcast talked about vCNS, vCloud Network and Security. They don't actually like using vCNS anymore, and they were specifically talking about vShield Edge. And I'm actually thinking about, okay, we can scale bandwidth pretty easily on most security products. It is actually connections per second and new sessions per second that actually have problems scaling. And I think they need to be able to scale to cloud sizes really, really quickly.
Well, and then is that, and just to be specific in their case, and this is going to be generally true, does that mean being able to deploy, more vShield Edge manager instances, such that the number of edges under management by that manager is kept to a performing limit, right? And then you have to have some other tool sitting on top of all those managing instances to provide the cohesion and coherent security policies that are actually required. And again, you have to. Go ahead.
Go on.
Well, the thing I was going to say, and the linchpin to that is a orchestratable API at the management layer, and then a tool that provides that orchestration.
Well, it's even more than that. It has to be a high-speed API, because say I have to shove down 20 new firewall rules, and there's 10,000 already on the system. If that takes way too long, and I have to do that across 1,000 different firewalls, it could take possibly hours to be pushed out. And then by then you already been hit. You were trying to be preventative. It took an hour to go out. I mean, there's a time scale in here most people don't realize when you start talking about scale of data centers.
Right. Yep.
Time makes a huge difference.
The scenario you described would not be very good, right? And so obviously,
I'm sorry, go on. I missed the first part of that.
The scenario you just described would not be good, right? Something that if it takes hours to do a rule push, then you've got to rethink how you're doing this. Because I think clearly for machine-driven, you want if not near real time, you want seconds or minutes at most. Right?
Absolutely.
Hours is not going to make it, right? Because then a task gets spread through your whole data center in a few minutes.
So even you've been working with with CA when they have large-scale environments that they work with. What's the largest scale that you have?
Sure. Sorry I'm a little late getting on, you guys. Get the headset on here. So, we have customers with some really large-scale environments, and I hear what you guys
define what you mean by large scale. We've been talking about
10 to
millions of nodes.
10 to 20,000 nodes.
Okay. That's, to me, a medium-sized environment. For security automation, that's table stakes. You've got to be able to handle that.
Yeah, well, the thing I was thinking about while you guys were discussing this is that there's two parts. One is the number of nodes in your environment, which sounds like there's different sizes. But the other is number of environments as well. we were talking about how many vCenters you have and how you need vCloud Director to manage them all, and how are you going to update the rules across there. What happens with companies that have more than just VMware, right?
Hey, even you got to speak up or change your phone. You just faded all in and out.
How about this? Is that better?
Just a little bit better. Go on.
So what happens with companies that have more than just VMware in their environment?
That's why we were talking about in general. We're not specifically talking about vCenter.
So you have to
and that's how this conversation started, because we started off the conversation discussing VMware's investment in Puppet, and Puppet is certainly a more than VMware orchestration tool.
Right, absolutely. And there's some companies that actually update the firewall tables not just on their hypervisors, but physical firewalls as well, which can be from different vendors, and then also the IP tables and Windows firewalls within the guest. And not all cloud environments are virtual, so we have to consider those environments as well.
Absolutely. If you're talking about a massive data center, the scale is not just the scale of the virtual environment, it's the scale of the physical environment. You may have to push rules out to all of your switches for a new bus zone. You may have to talk to all your controllers for OpenFlow or VXLAN.
Perfect. So we're setting the stage here, and I'm just kind of explaining to you some of the things that I've seen out in the field. We've run into these scale limitations and understand there's going to be delays in updating all those firewall rules. So typically, they have a different environment. So I'll give you some real-world examples. There's going to be a QA environment, which has, everyone knows the QA environment is this /16 IP address. It might be something like 10.1.0.0/16 is QA. 10.2.0.0 is production. So you got a .1 is QA, .2 is production. Everything inside production. These are the old ways of doing things, right? Everything inside production can talk to each other. Everything in QA can talk to each other. And from QA to production, we have certain big, giant firewalls that manage what QA can do to production and vice versa. So that scales to a point when you have these physical data centers. Once you start talking about cloud, that's where we realize that those methods are not going to scale anymore, because we want to have mixed environments where QA and production are in the same physical data center, same network, rack, same switches, etc. So what we found is, I'll just tell you how one company is doing that, and it seems to be a trend that's taking off. And that is that the ACLs on the switches ensure that only the certain types of protocols that allow tunneling are going through these ports. So some ports are for infrastructure and control, and those have a different set of ACLs on them. And the other ACLs on the switches are allowing the tunneling protocols for the switches to go through. And
you're talking about OpenFlow, so okay, go on.
The tunneling protocols are only allowed through certain, through the hypervisors to each other. So there's class of service that they have to, first of all, categorize everything into. The number of class of service are very tightly controlled. You can't just make up a new one on the fly. And then based on the class of service, it determines which OpenFlow network you're going to be put into. So specifically, the VMware Nicira technology is being used, and that allows for the networks to be set up ahead of time. So any new machines get put into those existing networks, but the machines can be put anywhere in the environment. So we don't have to go update firewall rules.
Yeah, we weren't, but that's a little off our topic, because we weren't actually talking about physical infrastructure of that nature. But yes, OpenFlow does, or VXLAN or NVGRE.
I guess, long story short, what I'm trying to say is additional ways of securing the network don't scale, and companies have had to look for new ways to do that.
Absolutely.
But I'm not sure OpenFlow secures your network.
Well, let's just think about what Eben just said, because there was a lot to like there. First of all,
there is. There's a lot to like there.
First of all, it's not dependent on VLAN or IP address. Right? That's a good thing. All right? Second of all, he has multiple security domains. They're well understood, and objects are put in those domains, more or less automatically. And once in that domain...
Okay, I want to add to that, Michael.
Yeah.
They're only put in those domains automatically. If someone were to manually a machine in one of those domains, it would set off so many alarms. Everybody would be all over them. So we have to
Even
mark
better.
it as experimentation or something. So yeah,
right.
That's the thing that's different, is that only automation is used to manage these environments. So only the automators can do stuff. You want to do stuff, you must use automation.
So that's even better. But now, and this is and Ed, I don't mean to speak for you, right? But then we can agree. Then that makes the automator, a great thing to mess with.
Absolutely.
And it makes the open flow protocols and management stuff a great thing to mess with. But the other stuff. I mean, think about how many problems just go away in this architecture, right? So a lot of the complexity of the cloud has been turned on its head. It's actually now simpler, right? Because
actually, I don't think so.
Underneath the hood, it's complicated, but at the user level, it's simpler. I, as a user in this organization, I'm just, my VM is just where it's supposed to be, and it's got the security requirements it's supposed to have. I don't have to think about it.
Yeah, actually, you do, and I think that's the problem. Users don't care where that is running. All they care is that they can access that application. I could care less if a VM or not. I'm a user. I want Outlook. That's my application. My mail has got to work. That's all they care about. The IT team may care about virtual machines. They may care about physical machines. They may care about open flow controllers, and they may care about switching and all that. They have the stack. But the users don't care. They ordered a VM. No, they ordered an application. Let's be really clear about this. No user is going to go up there and say, I want that VM there because it has everything I need in it. No, they're going to go and say, I need Outlook, I need Word, I need Excel, I need...
No, you're absolutely right. I don't think we're disagreeing with you. But the point is, you ask for that VM, you're going to get that VM.
No, you're asking for that application, you're going to get that application. Ignore the VM.
You're not going to know whether it's VM or physical. You're going to get the application you asked for. It's going to automatically be provisioned. It's going to automatically be provisioned on a network that's got access to the right, email gateway with, spam filtering. All that.
In theory, you're absolutely right.
In fact, you can't work around it, right? Because if you attempt to go out a different email gateway, you'll be stopped. Because the network security domain that's been automatically configured for you doesn't allow you to do it.
If they've gone that far.
So guys, can I add a little bit to this, just a little color? So we have to separate between the types of as-a-service offerings, right? So we have infrastructure as a service, which we're talking about adding compute, new VMs to. If I have an environment, let's say it's that QA environment, and I have an application that I want to test, or I'm a developer, there will be let's call it, the mail application or the web application. So I have this new web application I'm developing. I'm going to ask for some machines. I might say I need 10 machines to develop this, and then I have those 10 machines. I get the IP addresses or whatever, and I can now log into them and manage them. Remember, we're trying to do as much as possible through automation. So I'm not talking about deploying an application yet. I'm just developer. So I might have Python, Ruby, my development environment, all those standard tools could be automatically deployed to that infrastructure, and then I'm going to develop my application. When I go to deploy that application, it's going to go through a continuous integration testing cycle. So I have to check it into the build environment that's going to build it and do this testing. It goes through a whole sequence of tests. And then we can promote it to production, and it gets deployed to those pools of servers.
How many companies did you know of actually go through automatic testing? Have intelligent developers that will actually understand secure coding.
Right.
So there's more and more. As part of their let me finish here. Have as part of their process a security review, either automated or by hand, And I can probably count on one hand the number of companies that do that.
What are we talking about? How people used to do things or where things are going? I'm explaining to you where things are going. There are more and more as-a-service capabilities being developed and delivered by startup companies all the time. And so you'll see in the open source community and DevOps community, you see these things coming on, and they're becoming more and more standardized. You talked about Puppet, for example. Chef is another tool. There's cookbooks for all these sorts of things, and once you develop a cookbook and use it in your QA environment, you can also easily use it in production. So these tools
does that cookbook imply that it's secure? You're talking about a crowdsourced group that doesn't necessarily understand security coming up with tools that are going to be used to automate a software-defined data center. Are they secure?
Well, what is security, right? So my point is, if you have a security control that says, I should not be able to SSH as root, or I should be at this version of PHP, or whatever that security control is, and you write an automation cookbook for it, or I don't know what Puppet calls them, a config check, then if you use the same config checks in development and production, you can be sure that you're quote-unquote secure according to your standards. And if you don't have that automated, then it's going to be a manual process. But the automation is now becoming more and more available, and we're shifting things to the left in the development cycle. So I know a lot of companies that kind of willy-nilly do whatever they want in development and QA, and then when it goes to production, it's running on different hypervisors, different firewalls, all sorts of everything's different. And the tools are now becoming available to allow you to do more and more, just like you would in production, but shifting it to the left in the development cycle, where you can now do it in closer and closer to the developer. The developers have a lot more access to tools that you would usually only have access to in production. That's all I'm saying.
No. The developers have always had access. They just don't want to use them.
But no. But you don't necessarily give them. The direction we're moving is that they get what they get, right? And they get
we're moving more towards platform. Yes.
They get a piece of infrastructure. Let's just focus on SSH, for example. If you go to Amazon and you get an AMI, right? You get an Amazon machine instance. Check me if I'm wrong, guys, but I've done this a few times. You cannot SSH as root into that instance. You get an EC2 user, and that EC2 user, in fact, you don't use password authentication for that either. You use SSH auth, use tickets, use public-private key pair. And you cannot SSH as root into that instance by default.
Right.
You can log in as the EC2 user using your public-private key pair, and you can sudo. You can do that, but you can't just SSH in as root. It's not up to you. Now, can you work around that? Can you log in as root and make the instance less secure? Of course you can. But you know what?
You know what happens, though? A lot of times you do that, you break the system to meet your needs, and then the config tool comes around and wipes you out.
Exactly.
And so you start learning that you need to go back to the source of truth to get that fixed. And that's the great thing about these config tools is you're programming things differently in the developers to where you're changing their behavior patterns. That's what's happening now. Is in order to
the developer of old said, I have to have root access, blah, blah, blah. I need to be able to get access to everything and anything.
Oh, no, I fired that guy. Look,
I represent that guy, yes. But the modern developer doesn't care. They need access to PHP, or they need access to Grails, they need access to Java. They're all
and we give them access. We just don't let them SSH in as root. They can SSH in as their user, and if we allow them, we let them.
They don't even let them SSH. They're using other tools to do that. They got IDEs to allow them to do everything they need to do. I mean,
yes, but that's even more
controlled. Anymore.
That's even more controlled. And in fact, the IDE. Let's talk about an IDE. Let's talk about Eclipse. Right? If you're using Eclipse as your IDE, underneath the hood it is SSH, or it can be. You can enforce that it is, but you can, as the owner, as the CEO or whomever, you set a policy and you say, hey, if you want to use Eclipse in our environment, fine. This is how you configure it. If you configure it any other way, guess what? It won't work.
And depending on the type of developer you have, they may or may not be willing to do that, accept that.
Well, they can work somewhere else. I mean, this is how modern development environments work. I mean, the thing about the IDE and the complaint that used to exist is, oh, that's too hard. You're making it harder for me to do my coding. That excuse is gone. The automation, in fact, that make it easier for you to do coding. So we talked earlier about Fortify and other code checkers. You know, it used to be all these extra steps, right?
Yeah, then
so
now they're built right in.
Now they're built right in.
But they're not really where they should be, in my opinion.
Maybe it's not, but they're a heck of a lot easier than they used to be.
I think they need to be right in the path of code submittal. When you start submitting code to your code repository, which is where it needs to go before it can actually be filled out and put anywhere else.
Well, you can make that
QA.
Yeah, in Git or SDN or these other tools, you can create hooks. You can basically force people to go through a staging process where these tools are run first.
Exactly.
Or before the commit completes. I mean, that's all doable nowadays.
Exactly.
I think that's
doable now.
To support Eben's point is you can make this automatic. You can make it behind the scenes, and you can just say, "You're not done, man. You know, Fortify said that you're using sprintf in an unsafe way. Go fix it."
Yep. Yeah. So
Ed,
that's exactly. That's a great. I'm glad you brought that up, Michael. That's what's happening. That's what's allowing us to be more secure with this environment. Is the developers are finding it easier to do their job because there's more automation involved, and they know that they're going to check things in and go through this process to get their code released, and they have more agile tools available to them to quickly check things in. If there's a bug, they can roll it back, or they can fix it right away and get it rolled out right away. But at the same time, the security team is setting up security as a service to every night. Sorry?
We got a lot of feedback.
Yeah, I don't know. Michael or I don't know, somebody else on the call is driving. Maybe you can mute your phone.
Pardon, muting.
Okay. So these security teams are taking advantage of this new DevOps process to plug in their security tools. So we were able to get Fortify to do static code analysis of the code, and we've tried so hard to get developers to use it over the last few years, and no developer wanted to take the time to figure out what to do. So now the security team is just randomly checking out code from the source code repositories, scanning it, and figuring out whose it is and providing those reports to them. And we're building up this environment. We're tuning our rules and policies. We have a few key application owners that we're working with. And it does take some effort from the security team to beef up this effort and resource it and make sure that there's people looking at it. But once you set it up, it pretty much runs itself. And then you start building it into the process.
But that's where we were talking about before, in that it doesn't actually run itself. It runs itself for what it knows. However, there are new attacks, new methods, new techniques coming out every day.
Yes.
And let's just look at a new attack. A new attack happens.
Maybe some package is vulnerable, right?
Well, no. Let's just talk generically here. A new attack happens. I detect that attack. My response should be automated, but I should automate feedback to those tools so it can look for one more thing. Without that last step, without that feedback step, those tools will eventually get out of date very, very quickly. And I don't mean depending on Fortify and Core Impact and those guys to update their tool suites. I mean, they will. But there's specific attacks against every environment. And in order to get the scale you need,
Hold on. Can I just make sure I understand what you're talking about? Because, I mean, we don't have attacks against environments. We have attacks against vulnerabilities. That's what we typically see.
We have attacks against applications. We have attacks against data. Those attacks are the nature of the vulnerability.
I understand. So there could be a firewall rule that's too loose, in which case you would mitigate that by fixing it. There could be something that's broken, in which case you want to...
I'm talking about if it's a firewall rule that's too loose, that would end up having to go, the response would end up having to probably go through a review by a person. Because if you...
You know what I've seen, to be honest?
You missed half the conversation, because if the person is not involved, you could actually tighten it up so much that you would impact the bottom line. I had a perfect customer.
Yeah, I was going to say that.
That needs a person involved.
Well, a lot of times the company's like, yeah, I know that root is open. I know SSH is open to the internet. That's a risk we're willing to accept right now because we're making so much money off this darn thing that we can't close it off. We have to have SSH for this third-party company to send us that data via SCP or something like that, right? And so we're like, wow, really? You guys are willing to accept the risk? You realize how crazy this is, you know? And so we look at improving the controls there, but it got flagged in a security scan, and so we make an exception for that. But now it's documented.
Well, and the thing is that you should be using something like SFTP and SCP over FTP and RTP.
Right.
So it's better than anything. And by the way,
right.
You shouldn't be allowing login by root. The username should probably be as cryptic as possible, and the password should be greater than 64 characters.
Yes, all these things.
All these things will help with that. And then you can say, yep, it's going to be allowed, but hey, I know which IP or range it's coming from. I can lock it down that way. But that, again, is all decisions made by a human. What I'm talking about is not IP-based or firewall rule updates. I'm talking about application attacks. In other words, something got in, went down a code path that wasn't expected. It did some damage. The parser needs to be updated. If I'm going to update the parser, I better update the test script for it immediately. And, hey, I might also update Fortify for parsers to say, look for these things now. The fuzzer.
Or what if there's how about this one? This is a pretty common scenario, actually, Ed. What if there's a library that you have in your organization that a lot of people are using in their code, and you find out that library that this guy wrote a year ago has a vulnerability in it and needs to be fixed, right? How do you know all the different places that are using that library if you don't have them being scanned and checked in?
That's what I was just talking about.
So by automating these build processes and getting the developers to use a similar methodology, the security team now can go do those checks on their own without involving the developers.
I'm not even talking about involving the security team, and this is where we're differing. I want a feedback loop. A known attack comes in, or a attack is detected. Don't care what it is. I don't care what it's against. It could be against the library. It could be against a PHP. It could be a parser issue. Once that detection is, part of the response has to be feeding back to the development process. Has to.
Totally.
In an automatic fashion, so security doesn't need to be involved. There's a far more developers than there are security folks.
Okay, let me tell you how this works at one of our big customers. They actually have the developers use their standard automated build environments, and they get a report when their build works or doesn't work already.
Yeah, we all get that. I've been doing that for years.
The security tools get plugged into those same reports. They're part of the bug dashboard.
Yeah, they should be. That's the automatic way of doing static code analysis and automatic pen testing on a build. Absolutely. But what I'm talking about is how do you update the automatic pen test suite? How do you update the static code analysis suite?
You have a centralized team of people doing that.
No, it has to be done automatically. And when you're talking about 1 million systems, you've got to start talking about feedback loops that actually do it automatically. New attack, here's the footprint of that attack because this is how we detected it. The response is to go back and say, okay, pen test suite, do you have a tool for that? If not, get someone to write it or automatically create it because, hey, I'm using Metasploit and that's pretty easy to do. Do you know what I'm saying? Big difference.
I do. The truth is that there are humans developing code, and we do have people getting reports of problems all the time. There's false positives, et cetera. So these vulnerabilities need to be vetted. There's typically...
That's at the build time. I'm not talking build time.
No, I'm saying we'll do dynamic code analysis of our public websites and find thousands of potential vulnerabilities all the time. And those are prioritized by order of threat. And then we take the top. Sometimes we're even getting hacked, right? People are already, not just our pen test is finding a problem, but we have, look at this fraud that happened over here. Somebody broke in and stole this person's information. And, oh, look, this is a code problem, right? So we find these problems and we file bugs against the application for that problem. If just that one application goes and fixes that one problem, then scale. That's the current way people are doing these, finding bugs, fixing problems. What I'm saying is DevOps and cloud with automation enable us now to improve on that process by finding that bug, finding that it was a library or this code, this common way that the developer wrote this one piece of code. And guess what? We can scan now. We can make a rule to look through all of the code base to find out where that's also being done in other applications and proactively open reports against those other apps who haven't been attacked yet. We don't even know, we didn't know before this that they had this problem, and say, hey, look, this one application over here had this vulnerability and was attacked. You are doing something very similar here, and we're flagging that for you and filing a bug to ask you to fix it. That's all I'm saying.
No, I agree with you. It absolutely has to be done. But it still involves a large number of people to do it. Not a truly automated.
Actually, this process I'm talking about, there's a team of 3 people that are managing 5,000 developers, the security patches for 5,000 developers, and they basically split it up by the tools. So the 3 people use different tools to do this. One of them is like HP Fortify. We also have Sensic, and there's a few others. But they've had to figure out how to work with the existing DevOps tools to get the DevOps guys to loop in those reports. So they're generating the reports from the security system, and those are getting now mapped into the DevOps tools.
No, it's exactly where it should be. That's not what we. That's right. That's the right way to do it. But you still have humans in the loop. The only humans.
Well, we're not going to get humans out of the loop until we do, machine coding, right? And we're getting closer to that with the work with bytecode and bytecode compilers, where you have intermediate. You sort of have a human developer at one point, but then the machine takes over. Right?
So
we're getting
there. I mean,
we are heading that direction.
It's funny because I heard people.
It is then possible to put stuff into the bytecode to
I heard people
automate
complaining about how cloud technology will cause people to lose their jobs, and there was like some guy who was a city or county government worker here in the United States was up on the stage asking a question to the panel, beating him up.
We had that guy on the podcast about 4 or 5 podcasts.
Yeah, he's going, I don't want to lose my job because of cloud technology. And now you're talking about developers, who are already actually pretty much a commodity. I hesitate to say dime a dozen, that's the phrase that comes to mind, but you can get a developer pretty much go out here and throw a rock and you can hit a developer. And
now we're talking about
developer. Automating those guys.
No.
The great thing
no. Automating the security testing of what they produce. That's what I'm talking about. I'm not talking about having any security guys in the loop unless it's such an egregious thing that they have to be there.
Yeah, there's compilers now like LLVM where, in a way your code is almost compiled all the way, and then it's run in a I don't want to call it a virtual machine because it's got a kind of different meaning in this context, but they actually run the code, right? It's dynamic. It's more than dynamic analysis as well, right? And code path coverage. And so there's advantages there, and then there's also the opportunity for machine optimization, not just for performance, but potentially for security as well.
Absolutely, and I think that we may end up having to go that route. There shouldn't. I mean, the feedback loops that we need, we don't have today. They don't exist, except that if they do it, it's an extremely manual process, and that manual process is getting in the way if we have a scale for software-defined data center that we're talking about.
Hey,
This has been
I know we're almost out of time, and I was late getting on. Did we talk about Steve Herod leaving VMware?
That's not a huge deal for us.
Well, I just think it's interesting in his on his blog in his goodbye speech. He talked about the software-defined data center, and that I think it's very interesting that he's moving on to invest in, just like you said, in other companies that are looking in that as well. So
absolutely, and I think that's
just complements what you're saying.
It's very good for Steve, and I think it's actually ultimately good for the industry.
Absolutely.
I have to drop off. Sorry, guys.
No problem. Well, thank you very much, everybody, for joining us on the 100th episode of the Virtualization Security Podcast.
Woohoo! Hey, 3 digits.
3 digits.
We just crossed it. It's like your odometer.